Okay. So on Thursday, we talked about polygons. We started talking about polygons. I strongly encourage you to have the prefixes with the number of sides on your study sheet. Strongly encourage you to do that because I will just say, hey, find the interior angle measure of a heptagon. If you don't know what heptagon is, you'll be in trouble. And if you're gonna ask me the day of the test, I'm just gonna walk away, right? It's gonna seem rude, but I'm just gonna be like, sorry, can't answer that, right? I wish I could, I really wish, but I did give you warnings, right? So we did that. After number 12, we call them n-sided polygons, so 13, 14, 35-sided, whatever. We just put the number of sides, and that's the polygon. This is on 203, if you're still looking for it, 203. And then we talked about regular versus irregular, and that for you to meet the regular criteria, you need to check off these two boxes. And so it's equilateral square would be for 3-sided, 4-sided, right? And then there's pentagon, hexagon. If all of them are the same, then they go on the regular. If not, they're irregular. So that's the difference there. Let's flip over to the back side where I give you all kinds of formulas. Remember, n stands for the number of sides. Let me just zoom out so you have an overview here. We did talk about 5 formulas that you need to know, right? Who else? Yeah, go. You need to know these 5 formulas because you'll be in trouble if you don't. Okay, so you have to have them either written on your study sheet, or if you have the yellow formula sheet, it also has them. It has them all like in a row on the front page. So if you don't want to use up your study sheet for them, you can always feel free to get them from there. I like to have them written down because I will add formula as well here. And I talked about that interior, the central angle, and the exterior angle. These formulas only work for regular polygons. That's very important to note because we're assuming that all sides are the same for this to work. And we spent some time labeling the interior angles in a polygon. Then we also labeled the central angle. There are various central angles, but I will only ever ask you to label one of them. We labeled the exterior angle right next to the interior, and we concluded, listen carefully, that I and E always add up to 180 degrees, and that they're called supplementary, right? Because they add up to 180. So we did that. So because of this fact, we can actually go to exterior angle here and add a formula, an alternative method of finding the exterior angle. So I will go, or exterior angle is going to be 180 degrees minus the interior angle. You can use either one. Okay, write that down. So the exterior angle can be found using this formula, right? 360 divided by the number of sides, or you can find the exterior angle by going 180 degrees minus the interior angle. I'm going to zoom in on that. And at the same time, watch this. I'm going to use the same train of thought. Go over to I up here and just write down, or I is going to be 180 degrees minus the exterior angle. So it's kind of just bouncing off each other there. So that's an or, which I would highlight because it often is a lot quicker than using the formula. Um, all of the angles can be decimals, but the number of diagonals, watch this, the number of diagonals has to be a whole number. If you use this formula and you don't get a whole number, you made a mistake. So you gotta go back. Okay? So we're gonna do some calculations here. At the bottom of this page, it says calculate interior, exterior, central angles of the following. So first thing you need to do, watch carefully because I'm starting easy, simple, only a couple of sides, but I have software that can make a 25-sided polygon. Okay, so put a check mark on where you're going to start counting and then count 1, 2, 3, 4, 5. This one has 5 sides, so you put down 5 sides. This is actually called a pentagon. We actually have a specific name for it. Okay? Don't double count sides. I don't know why, but it happens quite frequently, and I would like you to not make the mistake to get full marks, right? So let's find the interior angle first. Interior angle is actually, I'm going to write out the formula, n minus 2 times 180 divided by n. Not by 2, by n. Okay? You go I is equal to 5 minus 2 times 180. Brackets shouldn't scare you, okay? They're just there to help us. I don't like putting times with an x because sometimes we mistake that with the variable. So the interior angle of this pentagon is going to be found by typing this in. I just did that in my, right? This you can do in your head, right? Like the number minus 2. So 3 times 180 equals, divided by 5, that's 108 degrees. There it is. Yeah. How many interior angles does a pentagon have? How many interior? 5. Yeah. A triangle has 3. A quadrilateral has 4. So we're just going to label one right here. Call this I. This is the 108 degrees is right here. Okay? That measures 108 degrees, not 580. 108 degrees. So let's find the exterior angle. Exterior is 360 divided by n. That'd be 360 divided by 5. That would be 72 degrees. I would like all of you to get 100% when it comes to labeling the angles. I would really like that. So this is how you do an exterior angle. If you pay close attention, you cannot get it wrong. Pick any side on this thing. If you pick this one, which is the one I'm going to pick, I'm going to go up here so you can all see it back there. I'm going to travel along it, and as soon as I get to the corner, I'm going to extend it as if I keep going straight, right? I missed the turn. And so that angle right there between the dashed line and the side is what I call exterior. We label it with the letter E, okay? And that is 72 degrees. Can you see what they add up to? It's actually fairly simple to see. They add up to 180, right? So I will do this. Equal to 180 supplementary. Okay. They're always supplementary. The central angle is 360 divided by n as well. So 360 divided by 5. We already know that it's going to be 72 degrees. Where does the central angle go? You've picked the center. It says it all, right? Central, center, right? And then make a pizza slice. So you go to one corner and then go back to the center and pick another corner right next to this one. So if you want to go this way, that right there is your central angle. There are 5 in this case. You only label 1. But that one that you labeled measures 72 degrees. I don't know if you want to write that in there. 72 degrees like that. Exterior and central happen to be the same. Yeah. This is where you have to watch out. This is the common mistake for exterior angle, and it's wrong. Students will just go, I don't know, I can't remember. So they'll just take a corner and just go out like that. And they'll say, this is the exterior angle right there. Right? Like that's not right. Because look, if you travel along this side, it should be going here. Or if you travel along this side, it should have been going there. It's either way, but this doesn't work going out like that. So don't make that mistake, okay? All right. How about you try one? We're going to flip to the other side. Let's not do number 2. We'll do number 3 here. Figure out the number of sides and then find the interior, the exterior, and the central, and label it on that diagram as well. So do everything we just did on this polygon right here. That shall remain nameless for now. Go ahead and give. Oops. All right, let's look back up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That actually has a name. Right? Nonagon. So we find the interior angle. That's 9 minus 2 times 180 divided by 9. That's 7 times 180 divided by 9. That's 140. Okay. The exterior angle, watch what I'm going to do. 180 minus 140. What's my exterior angle? 40. And guess what? You got the same answer using the other formula, right? And then central angle, it's going to be 40 as well. So it's 360 divided by 9, and that's 40 as well. Okay. So labeling, you just do one of these, and that's I. I'm going to, how about this? I'm going to do my exterior here. I'm going to travel and then just keep going. So this is my exterior. That's just one of them. And central, I'm going to find the middle and just do one of these. That's the central angle right there. The diagonals would be way too messy. The sum, guys, pay close attention. I'm just going to go back once. You're like, how come we're not labeling the sum of all interior angles? You can't, right? It's the sum of all. It's just a fact. If you want to try this one here, this one is a hexagon. The interior angle should be 120. The exterior will be 60. The central will be 60 as well. If you want to give that one a try, I'm just giving you the answers there. I asked for a 10-foot screen. So those of you who are in the back, I know you're having a hard time sometimes. So let's see, fingers crossed. It's in the process. So this is a 6-footer. A 10-footer will probably be much better. Okay, let's go to 5 and 6. They're similar. I will do this one. You will do this one. Okay? You're going to do this one once I'm done this example. I put them side by side so you can try it right away. These are actually not too bad if you remember sine law, cosine law. So by the way, these are all regular. This doesn't work unless it's a regular polygon. Just write that down. Regular polys, both of them. If I take the center and I go out to one of the vertices, it would make sense. It would stand to reason that this should be the same distance, right? From the center to any corner, it will be the same. Okay, so this is the same as that. So we have 13 inches here. Because we're right now trying to find this value here, and we're also trying to find the perimeter, which we're going to deal with later. So for A, find central angle. Find central angle. I use this symbol for you guys, central angle, because this is the central right here, right? That's C, angle C. How do we find C? Well, we got to go 360 divided by M, which is 360 divided by, let's count, starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to 10. I'll make note of that, right? So 360 divided by 10 is 36 degrees. That is that angle that you're trying to find. Okay. Why would we want that? Well, we need an angle to use trig. So you have an SAS, cosine law. Because you have side, angle, side, right? So to find x, we square it and we go 13 squared plus 13 squared minus 2 times 13 times 13 times cosine of 36. X is square root of. Make sure you practice this so you know how to type this in. Some of you might have forgotten. That's 64.55 and keeps going. When I take the square root of that, I get 8.03 inches. How would I find a perimeter? Any ideas? The perimeter is the distance around, Quentin? Times 10, right? So sides times x, right? So we have in this case 10 sides, and we're going to multiply by 8.03, and that's 80.3 inches. And the reason we didn't use 4 decimals is again because this is an A and a B part. So for A, your answer is rounded to 2 decimals, and we use that one in our B section to figure out the perimeter. But if perimeter had been the question, the only question, you would have probably wanted 4 decimals and then round to 2 at the end. Okay, give this one a try. We're doing it the same way. See if you can figure that out based on what we just did. Actually, looking at my time here, before you do that one, I want you to write down this test review. I want you to already start reviewing for the test. So that's page in your worksheet booklets. It's page 14 to 19. I would call this test review 1 because I'll give you more stuff to do. This is in the worksheet booklet, right? You're like, which one? This one, right? I give you this. I give you a smaller, thinner booklet that goes with this, and it's that. And I will post the answer key, so if you try it, you will be able to check whether or not you got it right. And it's all kinds of polygons. A lot of it is polygon related. And so for the rest of today's class, just give that one a try. I'll give you the answers. How's that? Here in brackets for A, it's 1381. And for B, it's 151.91. Those are the answers to 6. So write that down, as well as the test review, which is pages 14 to 19.